Hi, and welcome back to Engine Shop Joe. Bruce had a couple very good questions. He's going to be replacing a diesel particulate filter, which we all know is a bit of work to get out and on the floor. And he's asking if he should change his diesel oxidation catalyst while that assembly's out. My answer is if the diesel oxidation catalyst is doing a good job, I wouldn't change it. It's probably in the neighborhood of $1,900 or $2,000 for that part. And if it's doing this job, there's no reason to change it. The DPF and the DOC are dipped in the same chemical when they're made. The DOCs have a second coating, if you will, painted on the side or brushed on the side that the exhaust gas comes into. They call that face painting. They've been doing that for a number of years, and they did that to make them better burn the soot that hits the face and sticks to it, because remember, soot is sticky, and that helped to not eliminate but really slow down the logging of faults for face plugging on the catalyst. If the catalyst is doing its job, there's no reason to replace it. So how can we tell if the catalyst is doing its job, the diesel oxidation catalyst? Well, there's a couple ways. We can look at after treatment regen history and insight. And there's two different places. One screen is after treatment diesel particulate filter catalyst efficiency, and that's a number on a graph of 1 to 10, or a chart I should say of 1 to 10. And if the closer it is to 1.0, the better the catalyst is doing efficiency wise. In fact, a brand new catalyst would probably be 1.0. And then as the catalyst starts to lose its efficiency, the numbers drop to 0.99, 0.98, 0.97. And I see a lot of DOCs that have been in for 500,000 miles at 0.95, and they still do a good job. If you get much below 0.95, then if the assembly is going to be out, it might be a good idea to change it. Another way to determine if you should replace it or not is by looking at after treatment history. And I'm going to show one slide and then a couple illustrations to help us see that. So let's take a look at that. This is the insight screen that shows you the catalyst efficiency. Over on the right, you can see that this catalyst is running at 0.95, and it was still doing an acceptable job, so there was no reason to change it. This shows you the last 10 occurrences, just like the regeneration history shows you the last 10 occurrences. This is the regen history in Insight, and if you have normal particulate filter differential pressure, that's the far right column, and this is pretty normal. Then you can look at the temperature columns. Notice on the left inside the green rectangle, it says maximum diesel particulate filter intake temperature. Well, that's catalyst out, DOC out. So the DOC out, where those three arrows are, is a little bit higher than the filter temperature out. And that means that when it was in this regen, and this was a driving regen, these three, while it was in the regen, the DOC was making more heat than the diesel particulate filter. So that would tell me the DOC is in good shape, and I would reuse it. So if you have access to Insight and you can do a data logger and log it, you can graph that so it kind of looks like this. And this is hand drawn, it's not actual graph, but it does represent what you'd see with a very healthy DOC. And you can see that the DOC is riding above the DPF temperature, and it's not touching the DPF temperature, but it's a little bit hotter. And that's what should happen, because the DPF's job is just to burn soot. Now, I said to do two in a row, 2 regens in a row. The reason you do that is the first one burns anything out that needs to be burned out. And then the second regen that you do, you're just looking at pure temperature and the efficiency of the elements. So on the second regen, if it looked like this and the DOC temperature was hotter than the diesel particulate filter temperature, you're in good shape and the DOC is in good shape. I would leave it in. This is just another drawing that I did, but in this drawing you can see that the DOC temperature, or the red line when graphed, is down below the green line, or the DPF. And I have seen actual regens that look like this, and it can be for a number of reasons. It can be because the catalyst was damaged from a failed EGR cooler that was a slow leak, and it was driven a while, and a few gallons of antifreeze over the course of a few weeks made it back and just coated that DOC element, and so it just lost efficiency. So when you see this, the diesel particulate filter is doing the work of the DOC, and if you make it do that too long, it's going to start cracking, it's going to fail. So when you see this, you do need to replace the DOC. The second question was, can the engine's horsepower be uprated to 650? And the answer is no. The maximum horsepower for on-highway automotive that you can ever go to is 605. Torque can go to 2050 if you have the right transmission, the right clutch, and the right rear ends. The clutch is important. Most clutches are rated at 1850 unless the truck is set up for 2050. You can put a 2050 foot-pound torque clutch in if your transmission can take that rating. That's a rating that we use on our very heavy haulers, 605 horse and 2050 foot-pounds. But you can go 605 horse and 1850 foot-pounds. So if the transmission and clutch are rated for that torque, or the engine was that torque, and say you were at 550, if your CPL allows you to go to 605, the horsepower could be raised to 605. I will say this though, when it comes to pulling on a hill when you're in the higher gears, really it's all about the torque, not really the horsepower. The horsepower is kind of how fast the engine will wind up to get up to say 1800 from say 1300. But if you're going on flat ground and you're up say at let's say 1800, and you start up a mountain and it starts pulling down, and let's say peak torque starts around 1550 and goes down to say 1300 or 1250, the holding power that makes the engine stay on that hill and not drop mile per hour, that's the torque rating. And there used to be a setting, there still may be, called smart torque, and guys that had say a 500 or 550, and they had maybe 1750 torque or 1650, because that's what the tranny was rated at. Some of the transmission manufacturers approved in the top two gears, which would be 9th and 10th, they approved raising the torque from 1650 to 1850. So the horsepower rating would be kept down around 500 or even 475, but the torque would be raised to 1850 in just the top two gears. And to the driver, that made the engine pull like the guys out there with the bigger horse engines, because it had staying power. So that's my answer to the horsepower question, and thank you for joining me at Engine Shop Joe.